Hi, I'm Bob Tabor with LearnVisualStudio.net. Now, near the beginning of this series, I said that classes were a container for related methods. And you can see I have a new project called Simple Classes. Go ahead, pause the video, take the time to create a new project. To start off with, we talked about the console class, and we were able to access the related members of that class, like readline and writeline, by using the period on our keyboard. We called it a member access operator. So that gave us access to the related methods that have something to do with the console window. All right, and to tie that thought together with another lesson where we talked about simple helper methods and creating your own, we said that new methods should be defined within the body of a class. We even demonstrated how to create a new helper method by making some space beneath the code block defined as static void main, but inside of the code block called class program. Now, truth be told, in both of those lessons, I was intentionally oversimplifying the explanation about classes because, as you're going to come to learn, virtually everything in C# and in the .NET framework is either a class or it's somehow related to a class. And that's really the purpose of this lesson. I'm not really expecting you to, from this lesson, go out and be able to create your own custom classes to build your own custom applications. But rather, what I really want you to be able to do is better understand how classes are utilized within the .NET Framework base class library. By understanding that, hopefully it'll help build a mental model for you as you go to work with additional classes that are outside of the scope of the ones that we covered in this series of lessons. Now, the truth of the matter is that I couldn't possibly cover everything there is to cover about classes because it's such a vast topic. If you really want to learn about the power of classes, then you're going to want to learn more specifically about object-oriented programming. But that's a topic for another day. I want to present just enough information for you in this lesson so that you're comfortable with the basics of how to use the existing .NET Framework base class library classes and how to create your own super simple classes for the purpose of the next couple of lessons where we go into more depth on namespaces and things of that nature. Okay, so as I already noted, we already have a new project called Simple Classes. And suppose that I want to create an application that works with cars. Suppose I have a car lot business and I need to keep an inventory of all the cars that are for sale on my car lot. So to keep all related information about a single car in one container, I may want to create a car class. So what I'm going to do is position my mouse cursor beneath the closing curly brace for class program, and right beneath that I'm going to create a new car class. So class car, and then I'll do an open and a close curly brace beneath that. So first of all, the keyword class tells the C# compiler what type of code block that we're attempting to create. We give this class code block the name car, and we'll see how that's used a little bit later in just a moment. Now, what we define between the curly braces within our code block will be the members of this class. We've already seen how we can create methods as members of a class, but we can also create something called properties. Now, just a side note here, classes can contain other kinds of members too, not just methods and properties. But these two are the most popular members of classes. And you're going to learn more as you continue to work with C# and beyond the scope of this series of lessons. But in this lesson, we're going to be creating 4 properties. We'll create make, model, year, and color. Think of these as attributes of a specific car on our car lot. And then later on, we'll create a method as well. So a property defines an attribute of an instance of the class. We can set attributes in code, or we can retrieve attributes in code like we'll do in just a moment. And as we already know, a method defines a named body of code that typically represents something that a class can do, an action that it can take. We created helper methods in the previous lesson to do something meaningful, like perform some super secret formula calculation. But in our car class, we're going to create a method for the car to determine its value on our car lot. All right, so there are several different ways that we can create a new property within the IDE. I'm going to show you the easiest way to do it. This technique combines a shortcut within the IDE called code snippets with a shortcut in the C# programming language called auto-implemented properties. So you may see different implementations of properties in the future. Just know that they're all one and the same. Okay. So to do this, I'm going to type in the word prop, P-R-O-P, and then hit tab on my keyboard twice. Tab, tab. And you can see that it creates a little template for me to define a new auto-implemented property. And so you can see that as I now use the tab key on my keyboard, it tabs between int and my property. And this is where I fill in the values for this boilerplate. So I'm going to type in string tab tab make return or enter enter. All right. And so now I've created a property called make, and I'm going to repeat this process 3 more times to create other properties as well. So prop tab tab string tab tab model enter enter. Prop tab tab int, so I'll just tab off of that, year enter enter. And then finally prop tab tab string tab tab color. So these are some basic details about a specific instance of my car class. So it's important to understand what we've done here. We've defined a data type. Just like string or integer, this data type is a little more complex. It has more pieces of information, if you will, that are all related to the notion of a car. So now what I can use with this blueprint is I can create instances of the blueprint. Just like you take one blueprint for a house and you can create multiple houses from that same blueprint. So what we're going to do is go up to the static void main and create a new instance of our car class. And we'll do this car, my new car equals new car. So an instance of a class is known as an object. An object is not a class, and a class is not an object. Although sometimes you'll hear people kind of mix these terms together. I may even confuse those terms myself. The class is the blueprint. Once you create a new instance of the blueprint of the class, it's called an object from that point on. So what we've done is created in memory a space large enough to store a new instance of car. And now we're going to start filling in the details of one specific car called my new car. So I'll go my new car, and I'm going to use the period on the keyboard. And you can see that IntelliSense gives us access to the properties that we defined. So let's go ahead and just fill these in. All right, so here I set each of the properties of the new instance of car called my new car to their appropriate values. Now, you can see here that I'm merely hard coding these values right here in my static void main. If this were a real application, I would probably present to the user a graphical user interface in the form of a web page or a Windows application form, or even a Windows phone where they could type in the values here and have them stored to a file or a database or something like that. But I wanted to keep it simple for this first pass through, okay? So what I want to do is dissect this code. First, I use the name of the instance of the car class, my new car, to access each of the properties of the car, and I'm going to use the equal sign to set that instance property to some value. In this case, Oldsmobile is set to the make. Now, once I have a new instance of the car class and I've set its properties, I can do some useful things with the instance of car that I've called my new car. For one thing, it's a nice collection of all the properties that define the car in just one container. So I can do something like this now. Console.writeLine, and I'll use that syntax that we've used a couple of times already. And let's run the application. So you can see what I've done here. I've set the properties in this block of code, and now I've retrieved the values in this block of code. So it's very similar to what you would expect, but these are specifically setting the properties, and here I am getting the properties. All right, so that's why you see the get and the set in each of these property definitions. The next important thing to realize is that when I've created a new class, I've created a custom data type. Just like any other data type, as I said earlier, just like a string or an integer, it just happens to be a bit more complex. So you can use that data type in the remainder of your application. So just as a quick example here, I'm going to create a helper method inside of my class program. And I'm going to take as an argument a car. Now, I'm going to keep this extremely simple. I'm going to just return 0. The value of the car is 0, or I could probably just do something like 100. Just hard code it. But inside here, I can work with the car input parameter and get to its properties and even its methods inside the body of this, since I have declared the input parameter car. And I think that's another thing that we want to I want to point out is that you may thought it strange that I was able to use the same name for the class definition as the input parameter. The fact is that C#, again, is case sensitive, so those are in fact two different identifiers. And you can see even with code commenting, it recognizes this as the class definition and this as just an input parameter variable. Okay. And this is a convention you will see often. There are others like underscore, for example. But the point of this is that we can now use this class definition, this type definition, in other places in our code, and it's treated like a first-class citizen. It's as much of a class or a type as string is, for example. Okay. And so, if we were to, in this case, want to call this, we would simply go determine market value and then pass in my new car. And that's how we would pass our instance of car into our helper method called determine market value. All right, so as we said previously though, that classes are made up of both properties and methods. And so let's just steal the implementation of this. In fact, I'll comment this out. And we'll create a method called determine market value, and here we'll just return some value. Again, we could just do 0.0 or whatever the case might be. Now, it's important to understand that we can reference in the body of this method other members of the class by using a keyword called this. So for this instance of the car class, retrieve its color or retrieve its year or whatever the case might be. All right? And then we can simply access that method by using the member access operator and then calling determine market value, and it should return a double. So we could do that. All right, so this is a very simple example. We used a concrete example for this introductory lesson to classes. We used a car. Very concrete. It's easy to conceptualize and represent in a class because it's tangible and it has a real world equivalent. But remember what we were trying to accomplish in this lesson. We want you to better understand how classes are constructed and utilized within the .NET Framework Base Class Library. As you begin to build applications, especially in this series of videos, you probably will not be responsible for creating your own custom classes. I think your main exposure to classes are going to be those classes that were created by Microsoft and available in the Base Class Library. In most of those cases, the kind of classes that have been defined in the .NET Framework Base Class Library do not have real-world equivalents. They are not tangible. In other words, they're more conceptual in nature. For example, I might work with a class that represents a connection to the internet. I might work with a class that represents a stream of data like we talked about earlier. That's kind of a pipeline of data flowing from one place to the other. I might work with a span of time. These don't have tangible, real-world equivalents. We're not working something like we would like something in the real world. So we're using a very simplified example here. But as you mature as a software developer, you're going to want to invest more time and learning how to create your own library of classes that represent both tangible and intangible or conceptual things as a means of breaking down real-world problems into code that you can easily write. This process is called object-oriented analysis and design. Again, that's not something we're going to cover in this series of lessons, but you can learn more about that on Channel 9, on Microsoft.com, and then on my own website, www.learnvisualstudio.net. So to recap, a class is a data type in .NET, similar to those basic data types that you've been using like string and integer and so on. You can define a custom class with properties and methods and then create instances of the class, or rather create an object using that new operator as we saw in this line of code in line number 12. Okay, so there's still quite a bit to say about classes. I'm going to pick this thought up in the next lesson, so be sure you watch it. We'll see you there. Thank you.